Very good evening, distinguished guests, honorable colleagues, ladies and gentlemen. Welcome to the premises of the European Parliament for today's conference, Nanoplastics, the Hidden Connections and Emerging Risks to Human Health and the Climate Stability. This conference is being organized by Patriots for Europe political group and the ALLATRA Global Research Center. The science is not anonymous. This was a sentence I dared to say and write when justifying the rejection of the new planned EU climate goal for reduction of greenhouse gases by 2040. And as I dared, I was really roasted by the progressive guys. Why? Because I questioned the European Climate Bible, which is the Europe, as soon as possible, as fast as possible, is supposed to reduce the greenhouse gases, no matter on the costs, no matter on the add value, no matter on what's going on in other countries outside EU, and no matter on, let's say, indicia that there are other elements, human cost or not, that are also involved in the climate stability. And this is fully being ignored. So this is the reasons why, together with Patriots for Europe, we have decided to schedule a couple of meetings to discuss all the cross connections and complexity of the climate stability, climate change, sustainability, and also the public health. And the first of them is today on nanoplastics. Why? Because nanoplastics, compared, for example, to microplastics, are so small that their penetration to the cells and tissues is much easier. Also, they influence the CO2 absorption, for example, to the oceans, while, let's say, changing the vitality of microflora on the sea level. Simply, it's a matter of fact that nanoplastics have become a topic for not only the public health, but also for the climate. And this is the reason why I'm really glad that we could hold the debate today. And now is my nice honor to welcome the speakers of today's. So let me also introduce the two welcome speakers with introductory remarks. Mark Burns, pastor, chairman of the Spiritual Diplomats Initiative, and the advisor to the President Donald Trump. Welcome to the European Parliament. Marina Ovchinova from USA as well, the president of the ALLATRA International Public Movement. Welcome. Then we have the expert panel from the ALLATRA Global Research Center. Alexander Masny, the biochemist. Hello. Welcome. Anna Kotliar from Israel, specialist in geology and geography. Welcome. Sitting to my right, Dr. Kara from the Czech Republic, let's say applied mathematics. Welcome. Dr. John N. from USA, master degree, as well as I do, from chemical engineering. Welcome. And last, but very, very not least, Professor Antonio Ragusa from Italy, obstetrician and gynecologist, the first scientist that has proven the microplastics in the human placenta. Welcome. After the introductory remarks of our two colleagues, there will be debate into 4 blocks, and therefore there is just one simple housekeeping rules. There is a tight schedule, so please follow it as much as possible, otherwise I will have to be prudent. And now it's my pleasure to pass the floor to Mark Burns. Mr. Burns, welcome to the European Parliament. The floor is yours.
Thank you so much. First of all, to members of Parliament, your esteemed gentlemen, to all of the people of freedom around the world. I'm Pastor Mark Burns, and I'm truly honored to be here. Ladies and gentlemen, most dangers we fear are the ones we can see. fire, smoke, pollution in the sky. But today I want to talk about something ALLATRA has brought to my attention, something my global initiative, spiritual diplomacy, has since recognized as one of the key areas of work, something so tiny, yet carrying enormous impact, something that may already be inside of us, something that may already be embedded inside of our organs, and it is called nanoplastics. Nanoplastics are fragments of plastic measured in nanometers, thousands of times smaller than the width of a human hair. You can't see them, you can't avoid them easily, and that's what makes it the most dangerous. We were told that plastics was revolutionary, cheap, strong, convenient. We weren't told that plastic never goes away. It never biodegrades. It breaks down into smaller pieces. A bottle becomes fragments. Fragments becomes microplastics. Microplastics becomes nanoplastics. And when plastics reaches the size, it stops being just trash and it becomes biological. Because nanoplastics are so small, they can pass through the cells of membranes. They can enter the bloodstream. They can travel to the organs. Recent research has detected plastics particles in human blood, lungs, liver, placentas, and even brain tissue. This is no longer just an environmental issue. This is a human health issue. So how much are we all exposed? How dangerous are we all really? We breathe them. We drink them. We eat them. Nanoplastics have been found in bottled water, tap water, seafood, salt, fruits, and even inside our very homes, the very air we breathe. Every time plastic is heated, washed, or worn down by sunlight, it sheds microscopic particles. Synthetic clothing releases them when it's washed. Tires release them on the roads. Food release them when heated. Exposure is not occasionally, it is daily. Now here is the difficult truth. Science is still catching up. Nanoplastics are extremely hard to measure, but early studies are deeply concerning. They show nanoplastics can trigger inflammation. It can damage cells, disrupt hormone systems, interfere with organ functions. They may also disturb the gut microbiome, the systems that regulate the immunity, the digestive systems, and even mental health. There's another layer of concern. Nanoplastics act like carriers. They bind to toxic chemicals, pesticides, heavy metals, and so-called forever chemicals. They can transport these toxins directly into our cells. So they don't just add pollution, they multiply. And one of the most alarming discoveries is their potential effects on the human brain. Some studies suggest nanoplastics may cross the bloodstream and the blood barrier. The barrier exists to protect our most vital organs, to protect particles. Can these particles, if they penetrate, we're entering a completely new territory. Even more concerning, plastics particles have been found across the placenta, which means exposure begins before birth. For the first time in human history, we may be passing a synthetic pollutant to the next generation before they even take their first breath. Nanoplastics don't stop with us. They move through our ecosystem. Fish ingest the plankton. Birds ingest fish, and eventually we ingest them too. They alter our soil health. They interfere with the plant growth. They disrupt microbiological systems that agriculture depends on. This is a planetary 911. And I believe that even now, moreover, because of their small size, most everyday defenses were never built for them. Standard household filters are not designed to regularly and reliably capture particles at the nanoscale. Standard air purifiers are not designed to reliably remove them from either our air or our existence. Once these particles enter tissue, living tissue, the problem becomes even harder. You cannot simply clean nanoplastics out of the body cell. You cannot easily reverse what has already crossed biological boundaries. And even the solution we often release to not solve this part of the problem. Recycle may reduce visible waste, plastic that has already begun to fragment, disperse, and enter the air, which means this: even if plastic production slows down tomorrow, it would not undo the exposure that has already begun. This is not a problem we simply switch off or turn off. And when exposure continues, while understanding is still developing, the risks do not remain theoretical. They accumulate in ecosystems, in human bodies, and potential across generations. And that is why the awareness of this issue becomes a responsibility for all human rights, for all human beings, that we realize this danger. It is affecting all of us, regardless of your race, your color, your religion, regardless of your economic system. It is impacting the whole entire human race. That's why I'm here as a spiritual diplomat, to share this alarming message to those who would hear us, that something has to be done. I'm truly honored to be in your presence, to receive and to hear and to be one of the voices that calls a 911. Nanoplastics has to become a mainstream topic, and I'm so excited to hear these wonderful leaders that have a solution to this problem called nanoplastics. Thank you so much.
Thank you very much, Pastor Burns, for your inspiring introductory remarks. And now it's my pleasure to pass the floor to Marina Ovchinova, the president of the ALLATRA International. The floor is yours.
Thank you so much. Ladies and gentlemen, Mr. Knotek, distinguished members of Parliament, dear guest, it's a big pleasure for me to be here in the European democracy and to have this opportunity to discuss such an important topic. And thank you so much, Mr. Knotek, for bringing the topic of nanoplastic to the parliamentary level. It's very important, and I truly hope, like Mr. Burns just said, that people will focus on that idea and continue to investigate. I represent ALLATRA International Public Movement. This is international community of volunteers from 180 countries, including scientists, researchers, professionals from different diverse fields. The activity of ALLATRA movement focus on comprehensive study of climate, geodynamic, and of course, environmental risks, advancing scientific awareness of these threats. The international dimension of our work is implemented through participation in the key global platform. Over the past 2 years, our participants took part in COP16, COP29, COP30, the other UN and OSCE events as well. At the beginning of 2026, in the United States, under the leadership of Pastor Mark Burns, the spiritual advisor to the President Donald J. Trump, and thanks to Pastor Burns, initiative Spiritual Diplomacy, a series of high-level human rights event was held on the ALLATRA platform within the US Capitol and Congressional Complex as well. In the scientific dimension of our work, our research platform, the ALLATRA Global Research Center plays a pivotal role. It is an independent analytical center officially registered in the United States as 501c3 nonprofit organization and also listed in the European Union Transparency Register. And today's conference is based on the 2025 report, Nanoplastic in the Biosphere, from molecular impact to planetary crisis, prepared by specialists of the ALLATRA Global Research Center. And it's my particular honor for me to share with you that one of the inspiration behind creation of this report was the apostolic blessing of Pope Francis received by ALLATRA movement in 2024 in recognition of our environmental protection activities. And in 2025, Pope Leo XIV also extended his blessing to the volunteers of ALLATRA movement as well. Of course, with the moral support of the Holy See, together with years of interdisciplinary research on micro and nanoplastic conducted by representative of our Global Research Center, formed the foundation for the popular science documentary Nanoplastic, The Threat to Life, which premiered in November 2025. The film has since received several international recognition, including awards at the festival in Mannheim, the London Independent Film Awards, and the Latitude Film Awards. Also joining me at this podium today are representatives of our research center who have traveled here from the United States, Israel, Germany, Czech Republic. And you need to understand, while they represent only a portion of a much broader international scientific consortium, one that includes experts affiliated with leading institutions around the world, they are here to present the collective research findings and analytical conclusions of the ALLATRA Global Research Center, including a comprehensive assessment of the potential consequences of micro and nanoplastic proliferation for human health and ecosystem integrity. And we invite all participants to engage in a professional, responsible, and constructive dialogue on this issue in a spirit of good faith and mutual respect. Thank you very much for your attention. And right now, it is my honor to introduce our keynote speaker, Dr. John Ahn, an expert in chemical engineering and sustainable technologies, holding a PhD from Technical University of Munich and MBA from INSEAD and a master's degree from the University of California, Berkeley. Within the ALLATRA Global Research Center, he focuses on the environmental impact of plastics on human health and planetary system. Dr. Ahn, the floor is yours.
So, honorable members of the European Parliament, esteemed colleagues, ladies and gentlemen, thank you for the opportunity to be here. It's an honor to speak on behalf of ALLATRA Global Research Center, along with my colleagues here. Today, we have convened to discuss a topic that, until recently, was perceived primarily as an environmental issue, but is now increasingly relevant to medicine, climate science, and public policy. The topic is micro and nanoplastics and their emerging risks. For decades, plastic pollution appeared to be a visible problem. Bottles on the beaches, debris in oceans, waste in landfills. Yet recent findings suggest that the most significant consequences now occur at scales not visible to the naked eye, at the micro and nanoscales. It is well established that plastic does not readily biodegrade. Instead of disappearing, under the influence of solar radiation, temperature fluctuations, and mechanical stress, plastic materials continuously break down into smaller and smaller pieces. Plastic does not disappear. It changes scale. And when scale changes, so does the nature of its interaction with the environment. Today, these particles are present in the food that we eat, the water we drink, even the air that we breathe. They've been detected in some of the most remote places, from the pristine mountain regions to the depth of the ocean, and within the human body. Our discussion will begin with a fundamental question. What happens when synthetic material designed for durability becomes a virtually permanent component of the environment and part of our bodies? To address this question, we will take an interdisciplinary approach, examining the issues across several scientific disciplines. We'll first examine how micro and nanoplastics form, how they circulate through environmental systems, and how they enter and accumulate the human body. We'll then consider the potential health implications and the underlying mechanisms, including how surface charge may enhance biological interactions. We'll also broaden the discussion to the planetary scale and explore the potential influence of plastic particles on the atmosphere processes, cloud formation, and heat dynamics. This includes recent anomalies in ocean warming, potential interaction with a geodynamic activity, and a broader implication for natural disaster trends and economic stability. Today, the impact of micro nanoplastics represents a complex, systemic challenge at the intersection of public health, ecosystems, and climate. No single country, discipline, or institution can address it alone. For this reason, our meeting offers an opportunity to examine the evidence together and to define clear, coordinated path forward grounded in knowledge and collaboration. With that, it is my pleasure to introduce our first speaker, Ms. Anna Kotyar from Israel. Ms. Kotyar holds a degree in ecology, and she's a representative of the Scientific Advisory and Research Council of the ALLATRA Global Research Center. Ms. Kotyar, the floor is yours.
Good afternoon. It is an honor to address you today. Thank you. Plastic is no longer separate from the natural environment. It now functions within it, gradually destroying its natural processes. Since the mid-20th century, more than 9 billion tons of plastic have been produced. It has become one of the most widely used materials and is used in almost all areas of life, from transport and aviation, medicine, cosmetics, and household goods. However, less than 10% of the total volume is recycled, and the bulk of it is accumulated in the environment. For example, a plastic bottle that does not disappear over the time but breaks down into particles the size of a grain of sand, less than 5 millimeters, and this is microplastic. Some of them we can still see, but many already looks like a dust. But this plastic dust continue to break down further. The particles become so small that they cannot even be seen with a regular microscope. They are thousands of times smaller than thickness of a hair and can be smaller than human cells and many bacteria. And this is already nanoplastic. But it is important to understand that when plastic breaks down, not only does the size of the particles change, but their properties change as well. If a plastic fragment with a diameter of about 5 millimeters disintegrates into particles approximately 1 micrometer in size, their number increases by many orders of magnitude. From a single such fragment, hundreds of billions of microscopic particles can be formed. At the same time, their total surface area increases dramatically. It can be thousands of times greater than an original fragment. And it is precisely that surface that determines how actively the particles interact with the water, air, chemical substances, and living tissues. In addition, as the size decreases, the role of surface effect increases, including the ability of plastic particles to acquire and retain a surface electric charge. The presence of a charge increases their physical-chemical activity. Consequently, plastic fragmentation means not just its mechanical destruction, but their transition of the material to a different state, from relatively inert light waste to a huge number of active microscopic particles. And for such particles, surface interactions become a determining factor in their behavior in natural and biological systems. And we will return to these consequences of this transition later. There are already more than 200 million tons of plastic waste in the ocean, and this amount is increasing every day. It was believed that the ocean was the final destination for plastic accumulation and the kind of global landfill, but it turned out to be only intermediate reservoir. Scientists estimate that sea breezes can carry up to 136,000 tons of microplastics ashore each year, and that is more than 370 tons every day. That is why coastal residents are among the first to bear the load of this impact. Today, there are 5 so-called garbage patches in the world's ocean. However, the situation in the Mediterranean Sea, which scientists are already calling the 6th garbage patch, is particularly concerning. But unlike the others, it is invisible because it consists mainly of microplastics. In this region, the concentration of microplastics in surface waters is 4 times higher than the area of so-called Pacific garbage patch, and this makes the problem particularly significant for residents of European countries. However, the impact of plastic is not limited to coastal regions. After rising into the atmosphere, air currents carry micro and nanoplastic thousands of kilometers inland, where they settle with the rain and snow. And for example, atmospheric precipitation of microplastics have been recorded in the mountain regions of French Pyrenees. A similar pattern has been observed from the Alps to the Arctic. In other words, micro and nanoplastic are present not only in the areas of active economic activity, but also in the places that have traditionally been considered pristine. Settling on land along with the rain and snow, these particles accumulate in forests, on plants, on agricultural lands, and in soils. There they interact with the root systems of plants. Microplastics are found in vegetables, fruits, and cereals, and then they enter the bodies of farm animals through feed and are detected in milk and meat. In other words, plastic is already embedded in the food chains. Studies show that microplastic can also reduce photosynthesis in plants, indicating potential yield losses of approximately 4 to 14% for major crops on a global scale. In fish and land animals, micro and nanoplastics are associated with inflammation, tissue damage, metabolic disorders, and organ dysfunction. This is no longer a question of food quality, but also of food security. Consequently, micro and nanoplastics should be considered not as a local waste problem, but as a new physical and chemical factor on a planetary scale. In this regard, the problem of microplastics goes beyond waste management and needs to be addressed with a framework of policies on public health, environmental sustainability, and, as we will hear later, potential climate risks. Thank you so much, and I pass the word back to John Ann. Thank you.
Thank you.
So micro and nanoplastics are everywhere, in the food we eat, the water we drink, and the air we breathe. When they enter the bloodstream, these particles can circulate through the body. They've been detected across multiple tissues and organ systems, including the liver, kidneys, heart and blood vessels, placenta, and breast milk, as summarized in a recent review published in Nature Medicine. These particles can also accumulate in the gastrointestinal tract, lungs, and endocrine and reproductive organs, where such accumulation is associated with potential disruption of the normal biological function. As someone with over 2 decades of experience in chemical engineering, I find this evidence deeply concerning. Micro and nanoplastics enter the human body continuously through ingestion, thermal contact, and inhalation. Exposure to these particles occurs without interruption. Now, among these pathways, inhalation may represent a particularly hazardous route. According to a study conducted in a coastal city in eastern China, individuals spending time outdoors may inhale up to 1 million microplastic particles per year. Recent findings suggest that when inhaled, the plastic particles, particularly those carrying surface charge, may migrate along the olfactory nerve through the brain towards the brain where measurable concentration have been detected. Among the organs examined in a recent study, the highest concentration of micro nanoplastics were detected in a brain tissue. The levels there were 7 to 30 times higher than those in the livers or kidneys. The researchers at the University of New Mexico estimate that in middle-aged individuals, each gram of brain tissue contains about 4,900 micrograms of plastics, roughly 0.5% by weight. In absolute terms, this amounts to about 7 grams, comparable to the weight of a small plastic spoon. Here, I want to point out that the situation may be even more concerning for children because their lower body mass and higher intake of air, liquid, and food relative to their weight can result in substantially higher exposure to plastic particles per kilogram, up to 4 times greater than adults by some estimates. This brings us to question whether internal accumulation of these particles is associated with measurable effect on human health. According to the European Academy of Neurology, residents of coastal areas with higher levels of micro nanoplastics showed increased prevalence of functional impairments, including 9% higher cognitive disability, 6% higher mobility disability, 16% higher self-care disability, and 8% higher independent living disability. While these findings do not establish causation, the associations are consistent with emerging mechanistic evidence and indicate that these particles can reach the brain, induce neuroinflammation, and disrupt cellular homeostasis. But the potential impact of micro nanoplastics is not limited to the particles themselves. Beyond their physical presence, micro nanoplastics may pose additional risks because they also carry chemical additives, including phthalates, bisphenols, polybrominated diphenyl ethers. Health impacts associated with just 3 of these additives were estimated at $1.5 trillion in 2015. Note that more than 16,000 chemical compounds are used in plastic production, many of which have not been comprehensively evaluated for long-term health human effects. Beyond chemical additives, another factor that may contribute to the biological impact of micro nanoplastics is surface charge. Plastic particles acquire and retain surface charge through the friction in air, also known as triboelectric effect, or by absorbing ions in aqueous environments, including biological fluids. The surface charge enhances interactions between these particles and cells, organelles, and biomolecules such as DNA and proteins. The smaller the particle, the stronger the surface-driven interactions, potentially amplifying their biological impact. As noted in a recent peer-reviewed article, plastic particles may pose significant environmental and health hazards, with surface charge playing a critical role in governing their behavior. An important consequence of these surface interactions emerges when the particle enters biological fluids. As described in a growing body of research, micro nanoplastics are rapidly coated by proteins, lipids, and other biomolecules, forming what is known as eco-corona. As shown here, the biomolecules gather around the particles in the bloodstream, forming this corona. This molecular coating can alter how the particles are recognized by cells and the immune system. Rather than being identified solely as foreign materials, they acquire a new biological identity determined by the molecule bounded to their surface. As a result, these particles may be internalized more readily by the cells. Studies suggest that micro-nanoplastics, particularly smaller nanoplastics, can cross several of the body's key protective barriers, including the intestinal barrier, the pulmonary barrier, the blood-brain barrier, and the placental barrier. Once these are cross these barriers and within the tissues, these particles are not readily cleared and they may persist for prolonged periods. In addition to persistence in the body, micro-nanoplastics may also increase viral stability. Viruses exhibit strong adsorption to plastic particles, and nearly 99% of the viral dose in some experiments was bound to their surfaces. Those that normally would lose viability rapidly may remain detectable on plastic surfaces for several days, and up to a week in some cases. Through this surface binding, micro-nanoplastics may function as a virus carriers, potentially contributing to prolonged viral persistence and influencing transmission dynamics. Here, it is important to note that these particles also exert direct biological effects. Research findings indicate that charged micro-nanoplastics may disrupt tightly regulated cellular processes essential for normal cell function and survival. They may affect intracellular signaling, activate pathways involved in programmed cell death, and impair mitochondrial function, thereby affecting cellular energy production. For more on this topic, I now invite Mr. Alexander Masny. Mr. Masny is a biochemist with a Master's of Science in Life Science Informatics, and he's a representative of the Scientific Advisory and Research Council of the ALLATRA Global Research Center. Mr. Masny, the floor is yours.
Thank you.
Thank you so much. It's a great honor to speak here today on this topic. And we'll have a look about what is known of the actions of nanoplastic particles and their electrostatic charge properties inside a living cell. As Dr. Ann already mentioned, there is much evidence today of potential accumulation of nanoplastics in the brain. But what is happening there at the cellular level within neurons? To better illustrate this, we'll now watch a short animation which schematically will demonstrate how electric charge of nanoplastic particles could influence living cells. So let's have a look at neuron signaling. Each neuron works like a tiny battery. It keeps a small difference in electrical potential between the inside and the outside of a cell. This allows it to send signals at the right time. Charged nanoplastic particles in it, in their turn, may disturb this balance. And the neuron can then behave irregularly, activating too early or failing to send a signal at the right time. If this happens repeatedly, communication between neurons becomes less precise, and the function of larger neural networks can be affected. Every neuron is surrounded by a membrane that contains small gates, so-called ion channels. When the neuron needs to transmit a signal, some of these channels open, allowing these charged particles, ions, to move rapidly into or out of the cell. This movement changes the electrical potential across the membrane and generates a brief electrical impulse. The impulse travels along the neuron and passes the information to the other cells, other neuron. Plastic particles may interfere with the normal function of ion channels. Because they can carry an electrical charge, they may interact with these gates, with the channels, and slightly alter their structure. As a result, the gates may not open when they should, or they may stay longer open when it's necessary. This disrupts the precise electrical signaling required for proper communication within the nervous system. One important finding about micro and nanoplastics is their potential to affect mitochondria inside in the cell. Mitochondria are often described as a cell's energy center. They produce the energy the cell needs to function, but they also help regulate metabolism, cell growth, and division responsive to oxidative stress, inflammation, and even program cell death, apoptosis. Because of the very small size and electric charge, nanoplastic particles can enter cells and reach even mitochondria. There, they may interfere with a normal mitochondrial function. When mitochondria stop working properly, it means the cell can no longer efficiently produce energy or carry out necessary functions, essential processes. Studies from 2025 show that plastic helps bacteria develop resistance to antibiotics. driving a crisis that medicine is increasingly unable to control. Why? Because plastic is the perfect platform for bacterial growth. When bacteria comes into contact with microplastic particles, they can activate a metabolic process related to electron transfer. In simple terms, we can imagine that plastic particles may exchange electrons with bacteria and act as an additional source of energy, sort of power bank. This mechanism is known as an extracellular electron transfer. And by gaining extra energy in this way, bacteria may grow more efficiently, divide more rapidly, and form dense, multi-layered biofilms. Such biofilms can reduce the penetration of antibiotics and make infections more difficult to treat. The range of diseases associated with the destructive impact of micro nanoplastics in the human body is extensive. And it's important to say that when we do not yet have done longitudinal human studies directly linking micro nanoplastics burden to specific clinical outcomes, however, we can say that the presence of micro nanoplastics in organs is confirmed. And in vitro mechanistic modeling and animal study shows that the harmful mechanisms of cell damage caused by micro nanoplastics are biologically plausible. I would like to briefly highlight several categories of disorders, some of which are currently demonstrating particularly rapid growth and affecting a substantial proportion of the population. Neuronal damage is associated with the development of severe, often irreversible conditions, including epilepsy, stroke, Parkinson's disease, Alzheimer's disease, and other neurodegenerative disorders. Having previously worked in a research institute in Fraunhofer on this topic on neurodegenerative diseases, including Parkinson's disease and Alzheimer, I'm particularly aware of really this complexity and societal impact of these conditions. So this topic is a really special issue of scientific relevance to me. And next we'll see that the work of researchers of the University Medical Center of Utrecht have demonstrated that immune cells exposed to nanoplastics die approximately 3 times faster than unexposed cells. And there are many more studies there. The impact, for example, have been associated with the development and exacerbation of asthma, progression of chronic obstruction of pulmonary disease, pulmonary fibrosis, the replacement of healthy lung tissue with SCAR1, an increased risk of malignant tumors of the respiratory tract. Micro and nanoparticles have been identified within atherosclerotic plaques, dense deposits in the arterial walls that narrow blood vessels and may obstruct natural blood flow. Their presence is associated with increased risk of myocardial infarction and stroke. Studies indicate that when microplastics are detected in plaques of the carotid arteries, the risk of major adverse cardiovascular events and mortality increased by approximately 4 and 5 times. A key mechanism may involve mitochondrial dysfunction induced by nanoplastic exposure. The accumulation of mutations in mitochondrial DNA combined with disruption of programmed cell death pathways reduce the body's ability to eliminate damaged cells and increase the likelihood of malignant transformation, cancer. Experimental studies in laboratory animals have shown that micro nanoplastics can accumulate in the testes, induce testosterone deficiency, and impair spermatogenesis. In animals subjected to chronic microplastic exposure, erectile dysfunction was disrupted within as little as 1 month. Equally concerning findings relate to female fertility. A 2025 study identified that microplastic particles were found in ovarian follicular fluid of 14 out of 18 women examined, with an average concentration exceeding 2,000 particles per milliliter. These data indicate that micro and nanoplastics interfere with the earliest stages of life, even prior to conception. In fact, we observe an overall decline of cognitive capacity. Age-related chronic diseases are increasingly diagnosed in younger populations. Last but not least, reproductive capacity is being increasingly compromised. The ability to conceive and give birth to healthy children is constantly decreasing. In summary, micro and nanoplastics can no longer be considered merely a matter of environmental pollution. Substantial evidence indicates that it constitutes interference with the fundamental mechanism of human life. What is therefore at risk is not only our present condition, but the well-being of future generations. This topic has now been continued by Professor Ragusa, who will address the impact of children's health. John will introduce Dr. Ragusa, a true pioneer in this field, and Dr. Ragusa will speak on the concept of cyber children, the presence of micro nanoplastics in placenta, and their impact on reproductive function.
So, dear colleagues, today I have the honor of introducing a scientist whose research has advanced our understanding of how deeply plastic pollution has penetrated the very foundation of life. Professor Antonio Ragusa is an Italian physician, obstetrician, gynecologist, and a researcher who was the first to identify microplastic particles in the human placenta. This discovery, published in 2021, marked a pivotal moment in modern research. The work made by Professor Ragusa and his team demonstrated that the plastic particles are capable of reaching the sites once assumed to be biologically protected, the very place where new life begins. His study attracted wide international attention. The finding that plastic particles could present in the placenta and therefore in the developing fetus raised a profound scientific and public concern. The same microscopic plastic found in the oceans and environment have now been detected within the developing human body. Please join me in welcoming Professor Antonio Ragusa.
Thank you. I'm sorry, but I'd prefer to speak Italian. It's my native tongue, so I'm much more comfortable expressing myself in it, especially since I know there's simultaneous interpreting. Unfortunately, a few years ago, we discovered that plastics are present in the human placenta. Let me digress a little bit. Here you can see photos of plastic fragments found in the human placenta. This brief digression is necessary to show you that the very same plastics present in the oceans and seas are found in the amniotic fluid and inside our children. It's the same plastic because everything on Earth is interconnected and interrelated. When we made this discovery and published it, the news spread all over the world. Many media outlets showed interest. We introduced the term cyborg baby, that is, cyborg children, because these children are no longer just made of organic material, but also of inorganic. This term has gained popularity in international literature. Later, a lot of evidence emerged that plastics are inside the uterus and fetal placenta. We also checked if they were present in breast milk, and unfortunately, we found it there too. Many organizations became concerned. They said, "Does this mean mothers shouldn't breastfeed their babies?" No. Breast milk remains relevant even if it contains plastics. It is the best food for our kids because artificial mixtures contain even more plastics than breast milk. So, there's no other option. The only solution is to reduce the amount of plastics that mothers consume during pregnancy. There are certain methods, attitudes, and behaviors that can be adopted on an individual level to improve the situation and reduce the amount of plastic one ingests. This is a watercolor. It might look like a photograph, but it's not. It's a watercolor made by the greatest living watercolor artist, who was partly inspired by our research. I believe that on topics like this, very sensitive topics, knowledge must not remain exclusive to scientists, but must spread to the general public. Therefore, we should seek cross-pollination, interact with journalists and art workers. This topic should move beyond university lecture halls. After we discovered plastic in the placenta and human milk, we asked ourselves, Where exactly was it in the placenta? How was it localized? And we located it, as you can see in these photographs, inside the placental cells near the mitochondria, which have already been mentioned to you, and near the endoplasmic reticulum. We discovered that the closer the plastic gets to the mitochondrion and the endoplasmic reticulum, the more these small intracellular organelles are morphologically deformed. Their shape is altered. And strangely, the plastic does not enter the cell nucleus. It is not yet clear why it remains in the cytoplasm, in the peripheral area. However, if you look at this beautiful illustration by Maria Mata, who worked with me on this research, you can see on the left a cell with its cytoplasm perfectly organized, mitochondria, endoplasmic reticulum, and so on. On the right, conversely, is a cell invaded, infected. Because plastic behaves like a microorganism, it infects, infected by microplastics. One can observe a state of anarchy where the cellular structures are completely distorted. Here you can see these very interesting experiments on mice, showing that exposure to microplastics alters fetal growth. You might say, well, Ragusa, those are just mice. We can do without mice. But that is not the case, because in humans as well, the amount of plastic found within the placenta is inversely proportional to growth. In other words, the more plastic there is, the smaller the infants are, the smaller their brains are, and the smaller their heads are. And these are humans, they are not mice. Moreover, the amount of plastic present in the human placenta is correlated with premature birth, which is one of humanity's greatest misfortunes. Currently, worldwide, this varies by nation and the degree of development within those nations, but currently, 10% of children globally are born prematurely, and this is a source of dramatic disability across the world. It is the most significant source of disability globally, and this disability is correlated with the amount of plastic present in the mother's placentas. Other conditions, such as cholestasis, for instance, which is a significant disease, are also correlated with the amount of plastic in the placenta, as is the fetus's ability to respond to hypoxia. Perhaps you are unaware because you're not obstetricians like me, but for children to be born, they have to go through sort of a dangerous journey, a very perilous journey, and they face hypoxia. The more plastic there is in the placenta and the amniotic fluid, the less capable they are of coping with it. Unfortunately, this study from Hawaii illustrates how the amount of plastic present in placentas has increased dramatically over time. That is to say, if we examine the plastic levels from when I was born in the 1960s, fortunately, there was very little in my mother's placenta. But over time, this number has surged. These are the biochemical mechanisms that have already been mentioned, through which plastic causes damage to human beings. We don't have time to analyze them all in detail right now, but we're talking about inflammation, cytotoxicity, and cell death. When this happens inside a human being, specifically within the uterus, what follows are epigenetic changes. That is, our lives are altered. Therefore, plastic is capable of changing our lives starting from the womb. And it does change it. Here you see, for example, Alzheimer's, which we discussed earlier, or Parkinson's. But observe, something I am very keen to discuss with you is obesity. Obesity has been a phenomenon of the last 40 to 50 years, because when I was a child, obesity was almost non-existent. I attended a school with over 400 pupils. Only 2 were obese. Today, if you look at the rates of childhood obesity, you see nations, such as Mexico, where 30% of children are obese. These are the mechanisms through which plastic contributes to the development of obesity. Here you can see the increase in obesity across various nations in recent years. This slide is very evocative because it demonstrates how the quantity of plastic we discard into the environment is directly proportional to obesity. That is, to the growth of our waistlines. This is a point of significant interest, as plastic is obesogenic. It acts as an obesogen. If we examine all the diseases whose prevalence has increased dramatically in recent years, Almost all of them share a correlation with plastics. These are complex pathologies. Obesity is a complex condition. It does not depend solely on plastic, but plastic exacerbates this process. We asked ourselves, how exactly does plastic make a person gain weight? It is somewhat peculiar since plastic has no caloric value. So, what is the mechanism? Well, the answer is relatively straightforward. We conducted an experimental study in which we artificially infected certain placental cells with plastic and observed what happened to them. We saw exactly the same phenomena that we had observed in natural placentas. That is, those not subjected to our artificial intervention. If you focus your attention here, this is one of our micrographs showing a single cell. You can see the cell, and inside it, within the cell's cytoplasm, indicated by the arrows, you can see numerous bright spheres. These bright spheres are microplastics. They cluster together in the same way viruses or bacteria do, and they are of similar dimensions. Those we found are approximately 10 microns in size, very similar in scale. The cell mistakes them for viruses, bacteria, or antigens, and becomes activated in an attempt to destroy them. However, it cannot destroy them because plastic is indestructible. As a result, the cell gets altered, and its ability to respond is compromised because it cannot expel them. It can neither remove them from the cytoplasm nor destroy them as it does with viruses and bacteria. And this occurs because the cell does not recognize these particles. It may take a few million years of evolution before the cell learns to recognize it and handle it effectively. Plastic. As you know, and as has already been stated, the amount of plastic we discard into the environment is immense. Although I am neither a sociologist and certainly not a psychologist, over my years of studying plastic, I have developed some ideas as to why we human beings are so foolish as to flood our environment with plastic, thereby destroying it for our children and grandchildren. There are several reasons, which I describe in this work. We do not have time to explore them in detail, but essentially it stems from the fact that for millions of years, not thousands, not tens of thousands, but millions, humans perceived the environment as an enemy. And indeed, for millions of years, nature was an enemy. Imagine early humans, men or women alike, without modern scientific knowledge or understanding, standing in a forest in Borneo, knowing nothing, unable to read or write. Nature must have seemed truly terrifying to them. We have internalized this perception. We have absorbed it so deeply that even now we remain incapable of protecting the world around us. This is my final slide. It relates to a paper in which I draw a parallel between the ocean water and amniotic fluid in children. The symmetries, analogies, and similarities between ocean water, its specific concentrations of salts, magnesium, potassium, calcium, and so on, and amniotic fluid are astonishing. These two fluids are almost identical. Therefore, when we throw a plastic bottle onto the beach, it is as though we are throwing it into our mother's wombs, because all environments are interconnected. We are all part of a single, unified network. Can we do something about it? Yes, we can. Consider this. More than half of all the plastic produced worldwide is manufactured by just 20 companies. 20 companies that reap extraordinary profits. Yet the debt is paid by all of us, who gain absolutely nothing from this. Therefore, from a legislative standpoint, intervention is not impossible, although it is certainly not easy. I believe that since the world today is driven by economy rather than politics, we must make it economically advantageous to preserve our planet. There are mechanisms that can be used. I describe them in this work. They are not the simplest, but we can seize this opportunity to change the world. I will conclude my presentation with this final, very striking slide. You may not know this, but today the leading cause of death among sea turtles is plastic. Thank you for your attention.
Thank you, Dr. Ragusa. So far we have examined how micro nanoplastics interact with and disrupt human cells. We now turn to how the impact of these same charged particles extend beyond the human body into the oceans, atmosphere, and climate systems. To explore this topic, I'm pleased to introduce Dr. Jan Kara of the ALLATRA Global Research Center. He holds PhD in discrete mathematics and algorithms from Charles University in Prague, and his research focuses on natural disasters, geodynamic change, and the environmental impacts of micro and nanoplastics. Dr. Kara, the floor is yours.
Thank you. The impact of micro and nanoplastics on climate is an area of active research. One fact we already know, though, is that micro and nanoplastics do affect water cycle. So what does this influence involve? Water vapor in the air does not condensate into raindrops on its own. It needs particles to condensate around, so-called condensation nuclei. Naturally, these are particles of dust, sea salt, soot, or other aerosols. As Anna already told us, there is substantial amount of nanoplastics in the air, and the research published in journal Nature has shown that plastic particles in the air act as condensation nuclei for water vapor. When there are more condensation nuclei in the air, the same amount of water is distributed among more droplets. Thus, initially, these droplets are smaller, and it takes them longer time to grow to the size at which they start falling as a rain. But eventually, when the rain starts, it is more extreme, because more water has accumulated in the cloud overall. Thus, when the concentration of nanoplastics is high enough, they first contribute to prolonged periods of drought, followed by more intense rainfall and possibly causing flooding. Similarly to affecting rain, nanoplastics also affect how droplets freeze into ice. Normally, pure water droplets freeze at a temperature of around -38 degrees Celsius. In presence, the research from Pennsylvania University has shown that in presence of nanoplastic pollution, the droplets usually freeze already at temperatures of -18 to -24 degrees Celsius. Due to the fact that raindrops freeze at higher temperatures, hail is created at lower altitudes. This way, nanoplastic pollution contributes to more frequent creation of hail and creation of larger hailstones. On this slide, you can see graphs from European Severe Database showing how the frequency of large and very large hail is increasing in Europe over the last 20 years. Here you can see some samples of the hailstones. If we take long-term trends, then the chances of large hail in Europe are growing by about 20% per decade since the 90s. Similarly here, we can see how the chances of heavy rain are growing in Europe over the last 30 years. These events are causing significant damage, and nanoplastics are apparently contributing to the increase of these extremes. To summarize, micro and nanoplastics affect the condensation of water vapor and cloud formation, which leads to an increase in intensity of storms, thunderstorms, and other destructive natural phenomena. Since the effects of charged micro and nanoplastics isn't taken into account in our models, these particles are possibly also leading to higher inaccuracy of our weather forecasting and climate modeling. Now, let's move from the air into the ocean. The ocean and the atmosphere are a single climate system. Water has the unique capability to absorb enormous amount of heat. For comparison, just 10 meters thick layer of the ocean is able to absorb more heat than the whole atmosphere. Ocean absorbs heat during the day and releases it at night, thus smoothing out temperature fluctuations. Ocean thus plays a key role in maintaining planet's climate stability, acting as a kind of natural air conditioner. The ocean also removes heat from tectonic plates and releases it into the atmosphere. We hypothesize that large-scale pollution of the ocean with micro and nanoplastics is disrupting this precise cooling mechanism. Nanoplastic particles concentrate in the ocean in three main layers: at the bottom, at the surface, and in the middle in the area of thermocline, where the water temperature and thus density sharply changes. Plastic particles with surface charge interact with water molecules at the level of hydrogen bonds, and this alters the chemical and physical properties of the water, possibly slowing the heat dissipation into the atmosphere and thus contributes to creation of zones of overheating inside the ocean. We hypothesize that the concentration of micro and nanoplastics in the ocean is sufficient to affect the heat exchange within the ocean. This in turn may lead to less heat being removed from the Earth's interior lithospheric plates, cooling less. As the graph shows, the temperature of our oceans is increasing at unprecedented rates. In fact, over the last few decades, the rate of warming ocean has accelerated by 450%. Now, the ocean isn't warming only at the surface, where the ocean is heating from the sun and the atmosphere. In fact, the surface heating affects only the upper 700 meters of the ocean due to mixing. But as you can see from the temperature profile data, since about 2017, the whole depth of the ocean up to almost 2,000 meters is abnormally warm. So what are the reasons of such intense warming of the ocean? According to our hypothesis explained above, the first reason is the concentration of micro and nanoplastics in the ocean. Since mid-20th century, the amount of plastic pollution entering the ocean is rising sharply. And all of this plastics is degrading into micro and nanoplastic particles. Now, over the same time period, we see a steady rise in the ocean surface temperatures. In Europe, we are particularly affected by this. Microplastic pollution in the Mediterranean Sea is one of the most severe in the world. It's 7 times the global average and 4 times higher than in the Northern Pacific, the area widely known for plastic pollution. Thus, it is quite possible that micro and nanoplastic pollution is already significantly contributing to the rise of heavy rain, large hail, tornadoes, and other extreme weather phenomena we observe in Europe. Now, temperatures and other extremes aren't growing only in Europe. As you can see in the graph, year 2025 has been the 3rd hottest on record, only marginally colder than the 2nd warmest year 2023. Similarly, the amount of heat stored in the ocean, so-called ocean heat content, has grown by 23 zettajoules, which is, for comparison, about 37 years' worth of energy production of the whole humanity. Traditionally, this heating is attributed to the emissions of anthropogenic greenhouse gases. However, fast warming rate in recent years is significantly surpassing predictions of our climate models. Let me quote Dr. Gavin Schmidt, director of NASA Goddard Institute for Space Studies. The long-term trends we understand, and it's being driven by the greenhouse gases, it's being driven by anthropogenic effects. But what happened in 2023 was that, and then plus something. And that plus something is much larger than we expect or as yet can explain. This demonstrates how traditional climate scientists are confused by the recently observed fast warming of our planet. As you can see, the warming steadily continues in 2025 as well. On these graphs from a study published on January 9th in the Advances in Atmospheric Sciences showed that although in 2025 the surface of the ocean was not record warm in 2025, that's the graph on the right, the total heat that has accumulated over the year in the ocean was the highest since the measurements began. We are of the opinion that although anthropogenic greenhouse gases contribute to the long-term warming trend, they cannot explain currently observed fast heating, indicating there are other important factors that are impacting the climate and that are not taken into account. A factor we already spoke about is the pollution with micro and nanoplastics, which possibly impacts the ocean-atmosphere gas exchange, cloud formation, water cycle, as well as heat transfer within the ocean. However, we don't think this factor alone can explain the fast warming of the planet. Our hypothesis suggests that the geodynamic changes are another important factor contributing to the planet's warming. That is, activation of the Earth's interior increasing the geothermal heat flow heating the oceans from below, and thus consequently the whole planet. Let me now pass the word to John, who will be speaking more about these changes. Thank you.
Thank you, Dr. Kara. So I will now present an analysis from the ALLATRA Global Research Center on additional factors contributing to the ocean heating. Let us now begin with recent temperature records. From the spring of 2023 to the summer of 2024, the average global ocean surface temperature broke historical records daily. Dr. Rob Larter, a British marine geophysicist, commented, "It's quite scary, partly because I'm not hearing any scientists that have a convincing explanation of why it is we've got such a departure. But the impression at the moment is that things have gone further and faster than we expected." Professor John Abraham from the University of St. Thomas suggested that the previously unrecognized factors may be influencing the long-term ocean temperature trends, the factors that are not accounted for in existing climate models. As mentioned earlier, micro-nanoplastics may alter the physical properties of the ocean waters, effectively trapping heat within the ocean. But I want to point out that the plastic itself does not generate thermal energy. It only limits its release. This raises a fundamental question. Where does the heat come from? Recent studies show that the ocean warming is occurring not only at the surface, but also in the deep oceans. NOAA scientists reported that in the Argentine basin, at a depth greater than 4,500 meters, the temperature increased by about 0.02 degrees Celsius between 2009 and 2019. Heating such a vast volume water requires an enormous amount of energy, an energy equivalent to roughly 4 times Europe's annual consumption. A similar trend has been observed in the Weddell Sea off the coast of West Antarctica. There, the upper 700 meters showed little warming, while waters below 2,000 meters warmed at a rate roughly 5 times higher than the global average at comparable depth. Note that solar energy penetrates to the depth of about 200 meters, and even accounting for the vertical mixing, it rarely extends beyond 700 meters. Thus, solar radiation is likely not the explanation for deep ocean warming. So then, this leads to further question. What is driving the warming of deeper layers? A commonly accepted hypothesis proposes that the surface water are heated by the solar radiation and the atmosphere, with global ocean circulation transporting this heat greater to depths. But findings from a recent study at the Ocean University of China challenge that explanation. In this study, researchers identified what they termed subsurface marine heat waves, approximately 1/3 of which showed no surface manifestation. Another half appeared at the surface only during certain phases of their development, while during other phases, they remained confined to the subsurface layers. If atmospheric heating were the sole driver, one would expect the thermal anomalies to first emerge at the surface and then propagate downward. Instead, observations indicate that some heat anomalies develop independently of the surface warming. These findings therefore suggest that atmospheric forcing alone may not fully account for the observed dynamics, and that additional energy contribution from below should be considered. One such potential source is geothermal heat, the heat originating from the planet's depth beneath the ocean floor. This source has long been underestimated, yet many scientists note that it can significantly influence the ocean dynamics and thermal balance. Although geothermal heat flux from the Earth's interior is often considered relatively constant, it may vary over time due to processes such as intensification of tectonic and magmatic activity at depth. The potential connection between seismic activity and ocean temperature anomalies is an area of an ongoing scientific investigation. Numerous empirical studies indicate a complex relationship between them. For example, in 2010, scientists from the Institute of Earth Physics of the Russian Academy of Sciences published a study reporting a statistically significant connection between seismic activity and climate variability in the tropical Pacific, including El Niño events. Based on more than 30 years of observation, the authors found that El Niño events systematically follow changes in seismic activity with an average delay of approximately 1.5 years. A similar pattern was observed in long-term trends. During the observation period, sea surface temperature increased by about 0.1 degrees Celsius, while seismic activity energy released in the Pacific Ocean, that doubled. Professor Arthur Vitrito of the College of Southern Maryland reached a similar conclusion. He analyzed ocean floor earthquakes with magnitude between 4 and 6 in relation to global atmospheric temperatures. According to his calculations, since 1995, the number of ocean floor earthquakes along the mid-ocean ridges has increased. These ridges form a global system approximately 60,000 kilometers long where new oceanic crust is actively forming. Vitorino reported that the seismic activity in this zone correlates with increase in global atmospheric temperatures with correlation coefficient of 0.7. He also observed that the temperature rises tended to follow an increase in seismic activity with an average lag of about 2 years. According to his hypothesis, intensified seismic and volcanic activity along the mid-ocean ridges increases hydrothermal heat release into the ocean, contributing to ocean warming and subsequently to increases in atmospheric temperatures. In addition to tectonic seismic activity, underwater volcanism may also contribute to ocean heat flux. Current estimates indicate that about 75% of the Earth's volcanic eruptions occur beneath the oceans. Although the dynamics of submarine volcanism are inherently difficult to assess and remain insufficiently studied, observation records suggest increased activity in many systems worldwide. Data compiled by the Smithsonian Institution show an increase in the number of recorded eruption days per year, with erupted lava often exhibiting unusual characteristics, including elevated temperatures and chemical compositions associated with deeper mantle sources. The slide highlights volcanic systems identified in various studies over the past 15 years, where these anomalous characteristics are exhibited here. Europe is not immune to these developments. For example, the Vesuvius Observatory reports that the Campi Flegrei caldera in Naples, Italy, has entered a phase of heightened activity with recent energy releases exceeding levels recorded during the crisis of the 1980s. In Greece, the Santorini-Colombo volcanic system has shown renewed activity marked by earthquake swarms associated with deep magma movements. In Germany, the Lockersee volcano, dormant for about 12,000 years, has also exhibited seismic unrest. It is important to consider the possibility that increased heat flow from the Earth's interior into the ocean system may be associated with the observed intensification of seismic and volcanic activity. In this context, geodynamic processes at depth may represent an additional factor influencing the ocean temperatures and indirectly atmospheric temperatures. An intensifying phase of geodynamic activity already carries serious implications. But today, this intensification is coinciding with a growing burden of micro and nanoplastic contamination, potentially amplifying the planetary vulnerability. The convergence of these forces may compound risks and place additional pressure on economic and social stability. Leading scientific institutions and global risk assessment agencies report a structural shift in disaster patterns with both frequency and intensity increasing. To understand this shift, let us consider a fundamental mathematical concept: linear versus exponential growth. Linear growth increases steadily and predictably. Exponential growth accelerates. The rate of increase itself rises over time, outpacing the linear projections. Today, natural disasters, including storms, floods, and wildfires, increasingly exhibit patterns consistent with exponential growth. The World Meteorological Organization, major insurers, and leading research institutions have documented this acceleration in both disaster frequency and economic losses. In Europe, the total reported natural disasters, as well as heavy rain events, hailstorms, and tornadoes, show similar pattern. This exponential pattern requires a different framework for evaluating threats and planning responses. Traditional risk models built on linear assumption may no longer be sufficient. The compounding interactions between intensifying geodynamic activity, micro and nanoplastic pollution, and increasing natural disasters present a growing challenge to economic and social stability. Addressing this convergence will require an updated approach to risk assessment and preparedness. Micro and nanoplastics are not merely a pollution. They represent a systemic threat to human health and climate stability with measurable economic consequences. This threat operates through two reinforcing pathways, placing pressure on the foundation of long-term economic resilience. In 2023, the EU health expenditure reached 1.7 trillion euros, approximately 10% of GDP, with per-person spending increasing by 44% over the past decade. Current projections account for aging populations and trends for chronic diseases, but they do not incorporate the emerging burdens associated with micro and nanoplastics, which could place an additional strain on the healthcare systems. At the same time, disaster-related losses are escalating. Between 2009 and 2024, average annual losses increased by 54%, with Germany, France, Italy, and Spain among the most affected. These losses are placing increased strain on EU governments and financial institutions. While climate change accelerates plastic degradation, plastic pollution reduces climate resilience. Each dynamic reinforces the other. Yet the current policy framework do not reflect this interdependence. Plastic pollution is largely addressed separately from public health and climate strategy. What is required instead is an integrated framework that places micro and nanoplastic at the center of health, climate, and economic planning. To understand why existing approaches remain insufficient, I now pass the floor to Alexander Massenet.
Yes, thank you. When people first hear that micro and nanoplastics are already in our blood, our organs, even our brains, an instinctive question arises. How do I get them out of my body? Biohacking communities promise some detox protocols, supplements, saunas, and personal hacks to flush out micro and nanoplastic particles. But this approach fundamentally misses the point, because no detox can extract particles that have crossed your blood-brain barrier and is already embedded in your organs. And here is the cruel irony. The very solution promoted by blood purification contain plastics themselves. Plasmapheresis, hemabsorption, filtration devices. We are using plastics to try to eliminate the effects of plastics. These procedures cannot extract plastic from cells. They cannot neutralize surface charges. They cannot restore disrupted cellular pathways. As Professor Sajju Ganatra has stated, that there is no safe levels of these chemicals in the body. The goal cannot be slightly reduced for individuals' load, while the environment continues to saturate us with new particles every day. To see why current solutions fail, we need to look at a full plastic life cycle. Someone might say, let's reduce plastic production and use and ban plastic production more. So this is impossible now. Plastics are now deeply embedded in the modern life. Examine what will collapse: medical devices, food supply chains, electronics, constructions, our infrastructure. A full prohibition is simply not possible in the foreseeable future, and it's also economically disadvantageous, either at the level of individual countries or at the level of international economy. We turn to recycling as the supposed solution. But here is the paradox. Recycling generates more micro and nanoplastic particles. The mechanical stress of recycling plastic to shred particles faster than virgin plastic will degrade. We're not solving the problem, we are accelerating it. And here is the biggest issue no one talks about, and where we have no answer at all. Humanity has already produced 10 billion metric tons of plastic. Much of this now breaking down into invisible particles that circulate in our air, in our food, water, and accumulate inside our bodies. 100 million tons will continue fragmenting for centuries, even if we stop production tomorrow. The world ocean alone contains 200 million tons of plastic waste. Current extraction rates of ocean cleanup efforts are approximately 20,000 tons per year. This is less than 0.01%. At this rate, complete ocean cleanup would take up approximately 10,000 years, assuming we stop all new pollution today, which we cannot. So the problem compounds exponentially, and whether we stop production or not. The greatest danger isn't that plastic we haven't yet made or recycled. It's a micro and nanoplastic we are already living with. We cannot clean this up. We cannot filter it out. We cannot recycle our way out. So the solution, therefore, is not to eliminate plastics, but to ensure that there is no longer will threaten life. So what can we do?
So let me reiterate that the risk associated with micro and nanoplastics arises from several factors, including their chemical additives, size and shape, surface charge, and resistance to degradation. Taken together, these characteristics determine how plastic particles behave and interact with biological and environmental systems. As my colleagues have noted, plastic particles already present in the biosphere pose ongoing threat that must be mitigated. Yet we currently have no practical means of altering their chemical composition, size, or shape at scale. But one viable direction, at least in theory, may be worth exploring: the influencing their surface charge. The surface charge of micro nanoplastics plays an important role in determining their behavior in biological systems. Many naturally occurring nanoparticles, such as mineral dust, sea spray aerosols, and clays, also carry surface charge, but charge associated with plastic particles appears to differ in its persistence and its interaction dynamics. It can remain stable across multiple environments, including air, biological fluids, and this charge can enhance the particle's ability to, for example, penetrate cells and cross biological barriers, including placental and blood-brain barriers. It also enables the plastics to bind to DNA, proteins, and cell membranes, and to persist, accumulate within tissues, and to influence the water cycle and heat transfer dynamics in the oceans. Therefore, if the surface charge of the plastic particles could be neutralized or even partially be reduced, their biological interaction and uptake could be limited. So this could, in turn, lower cellular adhesion, reduce charge-mediated binding to DNA proteins, decrease absorption of toxic substances and heavy metals, and restrict transport across biological barriers. For these reasons, international research should focus on developing methods capable of reducing or neutralizing the surface charge of micro nanoplastics. Achieving this objective would require coordinated, large-scale international collaboration, potentially comparable to major scientific initiatives of the past, such as Human Genome Project. I now pass forward to Yankara.
Thank you. Dear distinguished guests, esteemed colleagues, members of parliament, you have just heard about the problems that nanoplastics cause for ecosystems, human health, and climate. Now allow me to turn to the main question. What do we do next? What steps can we take right now? First, we lack unified European standards for monitoring plastic particles under 10 microns. Each research group uses its own methods, its own classification criteria. Therefore, we cannot compare data from different studies from different countries. We cannot create a comprehensive picture of nanoplastic distribution across Europe. Imagine if each country would be measuring temperature using its own scale. We have to develop these standards. We also lack standardized protocols for studying health impacts. We have no unified methodology for assessing the effects of nanoplastic on human body. Some scientists study effects on liver, others on lungs, yet another on brain. But all use different approaches. Without some unified protocols, we cannot obtain reliable and reproducible results for making informed decisions. Third, we lack comprehensive studies that would evaluate and compare the impact of nanoplastics from all angles. Here, I would like to highlight the Horizon Europe research topic that was published last year about advancing knowledge on the impacts of micro and nanoplastics on human health as a good step in this direction. And fourth, there are no requirements for including nanoplastics in climate research. Science climate models still do not account for this factor. We study the influence of CO2, methane, aerosols, but we completely ignore nanoplastics, which can significantly affect climate processes. This is a serious gap in our scientific methodology, and therefore we think it is necessary to adapt climate models so they properly account for nanoplastic pollution. It is also important to grow public awareness of the micro and nanoplastic pollution topic. Studies on micro and nanoplastics impacts on health are increasingly being discussed in social media. The Eurobarometer survey from 2020 has shown that 94% of Europeans care about protection of natural environment is important for 94% of Europeans, and 88% of them are concerned about the microplastic impact. Given the particularly high level of microplastic pollution in the Mediterranean, 7 times above the global average, it is important to act proactively. Finally, let me emphasize that nanoplastics pollution is a global problem, and Europe cannot solve it alone. First, because plastic released into the environment in one part of the world degrades into micro and nanoplastics, which is then quickly spread throughout the world. Second, because the time is limited and the challenges in front of us are large. As a citizen of Europe, I would like to see our Europe make a significant contribution to the solution of the micro and nanoplastic problem. Perhaps European representatives could propose United Nations protocol for micro and nanoplastics pollution at the next climate summit. Or they could initiate a creation of an international research coalition with European participation. In conclusion, I would like to emphasize that according to our estimates, the window of opportunity for substantial progress is several years, not decades. Therefore, timely action is particularly important. I sincerely believe that we have all the capabilities to address this 21st century challenge. And now, let me hand back to John for the conclusion.
So, dear distinguished guests, esteemed colleagues, and members of parliament, today our world faces several systemic challenges: rising healthcare burdens, accelerating climate disasters, and contamination of air, water, and food systems. These may appear as separate crises, yet they share a common underlying factor: the micro and nanoplastics. Plastic particles are not simply pollution. They function as a risk multiplier affecting biological, environment, and economic systems. Our challenge is substantial. Plastic particles are already present throughout the human body and across the environment. Addressing it will demand transformative scientific and technological innovation. On behalf of ALLATRA Global Research Center, I would like to first extend my sincere gratitude to Mr. Ondřej Knotek for his leadership in organizing today's event and for bringing this issue of micro and nanoplastics to broader public and institutional attention. Also, many thanks to Pastor Mark Burns for placing this important topic on the agenda of his global initiative, Spiritual Diplomats, and for helping to bring this conversation to communities around the world. And my gratitude also goes to Professor Antonio Ragusa for his pioneering research and sharing his findings with us today. Through his work, the scientific community has gained deeper insight into the presence and potential impact of micro and nanoplastics in the human body. Finally, I would like to thank all the speakers and for all of you for your attention and engagement. We share a responsibility that transcends borders and politics, the protection of our common home. Thank you.
Thank you very much. Thank you very much for all your professional contributions. And now it's time for potential questions from the public. So I'm looking around. Is there any question or remark towards our distinguished speakers, distinguished guests?
I would like to ask Mr. Ragusa. He mentioned that amount of nanoplastic in placenta has grown over decades. Do you have some data regarding it?
Yes. There are at least 3 international studies showing that the amount of micro and nanoplastics within the placenta has been gradually increasing over the years. and the increase has been particularly noticeable over the last 10 years. This is because the amount of plastic that to put it into perspective, 90% of all plastic produced ultimately ends up in the environment. Some countries are more conscientious than others. Italy, for example, is very conscientious because it recycles 12% of its plastic. But there are countries in Southeast Asia, for example, that do not recycle anything at all. Thus, all the plastic produced ends up in the environment. And, as we have shown earlier, the external environment, that is, the seas and oceans, is closely connected to our internal biological environment, specifically the placenta and amniotic fluid. Since we are constantly dumping plastic into the environment and its amount is increasing year after year, it is obvious, both from a scientific and practical point of view, that the amount of plastic in our children and in our fetuses, even before they are born, is steadily and relentlessly increasing.
Grazie mille. Thank you very much for the answer, Professor Garuzzo. And any potential question? Oh, yeah, the madam over there. Please go ahead.
Good evening, and thank you very much for this very kind panel that we have tonight here, bringing such important topics for nanoplastic. I'm Anila Prethi, a journalist from Albania. Actually, Albania is not yet a member of European countries, but geographically we are in Europe. So as you know, Albania has a long coastline along the Adriatic and Ionian Seas. Based on your experience and the studies you have conducted on the impact of nanoplastics and plastic waste management, what are the minimum steps of small countries, for a small country like Albania, to have effectively monitor and manage the risk in its waters? And the other question is, how can these measures be integrated into the effective national legislation, considering the correct regulatory gaps that we have in our nation?
Thank you very much. And who is now interested to answer that question?
Yeah, I will start with some points. Indeed, like for a small country like Albania, its geographic position between the Adriatic and Ionic Seas, the issue of micro nanoplastic is particularly acute. And in correspondence to your question about these minimum measures,
I would like to begin with the context of today's discussion that we ever ready. The need to develop really a unified European standards for monitoring plastic particles smaller than 10 microns have already been rightly, right step. And this conference, we have discussed it and proved that actually it's very important to really do it all together with all countries. How this can be integrated in national strategy? So in our opinion, like a minimal yet effective step is really to, what you can take immediately, is to create supportive conditions for the scientists who are engaged in micro and nanoplastics research. Resources could be directed towards a research group focused on identifying viable methods, developing solutions on neutralizing the surface charge of nanoplastics. And we see this as an investment in the future of kids. And by supporting domestic experts, by encouraging them to pursue this fundamental solution rather than addressing consequences alone, the country can position itself not only like merely as an observer, but a leader in this advanced research and in protective technologies against nanoplastic burden. So I hope, I've answered.
Yeah, I'll just add that, another thing with that, like everyone can do is to raise awareness. I mean, like just as an ordinary person, you could, a lot of people, maybe not a lot of people, but some people are not aware of this invisible problem. It's just the micro nanoplastic is just everywhere, but we don't see it. So oh, people think, oh, it's not really a problem, but it is a problem. I mean, you have seen the data, you have heard what we've talked about, and it's invisible. But let's make that visible, and you can do that through just simply by talking to your families at dinner tables, or I mean, you're part of in a media. So I mean, just do what we can to best of our abilities, because I mean, like when we have such a big noise from just ordinary people, then that could help to raise the awareness and bring to the solution. I mean, a lot of times things don't come from the top to the bottom. Sometimes things have to come from the bottom to up, and this is something we can do as individuals. So that's what I want to add.
Thank you very much. I'm looking for another question. Oh, the madam in the very last row was first. Okay, yes, you.
Thank you so much. Thanks for the really interesting discussion. I was really curious, just thinking about some of the solutions that were being discussed, whether the panel has any opinion on the future global plastics treaty that's being negotiated. So negotiations are underway for a treaty to end plastic pollution. And at the moment, nanoplastics are not mentioned at all, and microplastics barely at all. So would just be really curious on your reflections about the role that a treaty could play in solving some of the issues that you presented. Thank you.
Okay, maybe so I'll try to answer. So sure, I think the treaty is a good thing because it will at least end addition of new plastic into the ocean or into the biosphere. Yeah? But I will also have to say that as far as I know, the treaty is already being negotiated for 3 years and we are still not there. So yeah, I'm hoping that it will come to some good closure soon. Like, let's say it is approved and then we stop adding the plastic into the ocean. That's certainly a good step, but as John was already saying, and Sasha mainly was saying, we have already the problem with 10 billion tons of plastic that's already out there. Yeah, and that's decomposing, and it's enough of it to cause us a lot of problems. So in this sense, I think this treaty is actually not enough. And we will have to come up with other solution how to deal with the existing plastic. And so far we don't even have the scientific understanding how to do this. So I guess like some treaties are a bit premature at this point, but we have to, let's say, get the common will to significantly invest in understanding and researching the problem.
Thank you very much. The next question was from the madam in the red shirt.
Yeah. Okay. Thank you very much for this very informative session. I note that you said earlier that there's no safe levels for micro and nanoplastics in us, but the reality is we can't escape it, as you've already also shared. And you highlighted a point that sometimes we do get action when it's bottom up. So just wondering if there's enough bottom up pressure, I guess, applied, if we could get more action from top down by legislation and rules, by having minimum safe threshold levels. Do you foresee that we will develop some kind of safe range or safe limit for the various polymer types?
Maybe I can initiate the answer to this question. As I outlined in the beginning, the problem here is that you don't see the problem, yeah? And also, as it is a multidisciplinary agenda, it touches, as I said in the beginning, the Bibles, so-called political dogmatic Bibles. Many politicians over the world, but also here in this house, in this Brussels bubble, that had really invested so much political capital in saying that, for example, the climate change is caused only by burning the fossil fuels, okay? And if you now come with the theory that there are some nanoplastics, microplastics, that, okay, can damage the health, but no one sees it so fast, but of course the studies are there, but it's not so visible problem yet. And at the same time, it destroys the Bibles. They try to be resistant because basically it would mean that at least one or two decades, they didn't say the full truth to their electorate. And what they try to do, those progressive guys usually, they try just to maintain their electorate, and they cannot admit a change. I'm coming from a corporate business. For me, if we had the company strategy and the time showed that the company strategy needs improvement, we did it. But for some political branches, political parties, simply if you go this direction, then you should change it. It would be a loss for them. Instead of turning it into occasion, they're just afraid of this. So I'm afraid that there really must be much more, to conclude the answer, much more pressure from the bottom to the up in order to persuade politicians across the party, because in the European Union, unfortunately, we don't have a majority system. We have 5, 6, 7, 8 political groups, and you have to find majority across them. Yeah, over the Atlantic, it's maybe sometimes a little bit easier. Pastor Burns, that you have basically 2 parties, and they are changing. Yeah? So, strong occasion for public to be more vocal on this topic. That's my answer. Thank you.
Okay, maybe I'll address the question about the safe limits. Yeah? So here it is important to understand first thing. So, with plastics, it's not so much about the acute exposure into the plastics. Yeah. So there is the current plastics you are inbreathing isn't that large. The problem is that the plastics is accumulating in the body over the time. Thus, that's the problem with the safe levels, because even though the levels are low, because you get exposed to them every day with every breath, essentially, then over the years, they accumulate and eventually they start causing problems. So that's the problem with the definition of safe levels, or that's the main problem of defining the safe levels. So at this point, of course, we could define the levels so low that if we consider the accumulation over the whole lifetime, you would say, okay, it's negligible. But I am of the opinion, although I have no data for this, that these levels would be so low that they would basically be impossible to reach anyway. Yeah, I don't think currently, at least given the current scientific knowledge on this topic, I don't think there are any safe levels. Yes, I'm sorry to. Yeah, that's what we know so far.
Yes, please, Professor.
A good question is why, if plastic is so dangerous for us, we live so long and we live more than our father and so on. Why? Because plastic don't kill you and don't kill us. Plastic don't kill. Plastic permit us to live along, but with a lot of disease. With a lot of disease. Plastic is able to growing the number of disease that we have. Also when we are baby, when we are infant, because infants today have a lot of disease that long time ago they are not. And so the response to this question is plastic don't kill, plastic ti rende malato, do disease to you, not kill. Thanks.
Thank you very much. I think we have time for the last possible question. Do I see a madam over there? Yes, please. Yeah, you. Yeah.
I have a very quick question. As a psychologist, if I decide to make a research based on your experience, to find or not a link between monoplastic and psychological disorders in public mental health, which variables will you suggest to use for this research? I must say that I come from Albania, so the needs there is very big. And I wanted to take this possibility to have a good answer.
I would highly recommend you to inform yourself with the report that I mentioned, the foundation for this conflict report. You can find more than like hundreds of peer review articles and their analysis, so that will help you literally start your own research in this topic and follow all the sources. So if I can ask technical team to bring this report to the screen, I would really appreciate. So you can take a screenshot. Thank you.
Mark, Pastor Burns, would you like to step in for final minute conclusion?
Well, first of all, I'm very encouraged to see nanomicroplastics coming more to the forefront. Thanks to ALLATRA and to Marina and the wonderful team in the United States, I was just introduced to this immense real problem that exists. Through their ALLATRA's extent research, I have become extremely alarmed about nanoplastics. And to see these wonderful esteemed scientists on this panel is encouraging to know that people are working on the problem. But it is, as one writer said, it is insanity to do the same things and expect different results. And so for me, this is ammunition that I need, Your Excellency, to echo this message around the world, especially at the highest level of government, and to continue to work with the European Union and our partners around the world to try to bring a resolution to this very real growing problem. So thank you so much for Your Excellency putting this on, and thanks to the wonderful ALLATRA scientists, to Marina and the wonderful team, and all of you that are around the world that are coming together. You scientists, you are making this a top priority. This is what spiritual diplomacy looks like, that you're willing to risk your reputation to save someone else. And this was all about the unborn babies, the neuroscientists, the Alzheimer's disease, all the effects of nanomicroplastics that we've learned in this wonderful panel is to make the human society a better place. So thank you so much for doing this. I'm very grateful.
Thank you so much. And also I would like to thank firstly to all the professional speakers for really valuable contributions, and we all could see how complex challenge we are facing. It's a global challenge. It's a new phenomena, new element that basically the world has not been yet used to think about, to consider in its risk management. Global coordinated action is, of course, needed here. And I'm really pleased that we could elevate this topic also on the floor of the European Parliament. And I believe we will be able to continue fighting in the same direction. Once again, thank you very much to all of you participating, helping out, and of course to the speakers. Thank you very much. And thanks to the introductors. Thank you.